Very good day to you, my students and viewers. Welcome to my YouTube channel. It's still your one and only tutor on this channel, Mr. Ike, aka Science Demystifier. Today, I'll be discussing with you Faraday's laws of electrolysis to assist those writing this current MR.IYKE examination and also to help you in your future exams. Now, without wasting much of our time, I would like us to look at the first law, Faraday's first law of electrolysis. Now, Faraday's first law of electrolysis states that the mass of element discharged during electrolysis is directly proportional to the quantity of electricity that passed through the electrolyte. Now, let me give you a little illustration. If this is the electrolyte, and we have these glass rods as electrodes, when you pass current into these electrolytes, certain quantity of the elements present in the solution are discharged at the respective electrodes, and the quantity of the element discharged is proportional to the amount of current supplied into the solution. So what it means is that the more you supply current into the solution, the more quantity of element that is being discharged. All right, so without wasting much of our time, I would like us to see the mathematical expression of Faraday's first law of electrolysis. From there, we solve one or two calculations to buttress our point. All right, so let's see. Faraday's first law states that the mass of element discharged, which is M, is directly proportional to the quantity of electricity that passed through the electrolyte. Now, mathematically, when we want to change the sign of proportionality to sign of equality, we introduce what? A constant. And that constant is called electrochemical equivalence of the elements involved. Okay, so don't forget that the quantity of electricity can be calculated. The quantity of electricity can be calculated by saying current times time. So what it means is that when you multiply the current supplied by the time taken, it will give you the quantity of electricity supplied. So if I should substitute, assuming this is equation 1, if I should substitute Q is equal to IT equation 1, my equation will change to EIT. So where IT represents Q and E is the electrochemical equivalence of the element. All right. So without wasting much of our time, let's go straight to this example 1. Calculate the mass of silver deposited by passing a current of 2.6 amperes through the solution of silver salt for 70 minutes. Now, if the quantity of electricity supplied through the electrolyte is not given, that means you need to calculate it. And if you look at this question, we have the parameters that will help us to find the quantity of electricity because it is fundamental. You need to find Q before you carry out any calculation, or before you further your calculation, you need to first of all find the quantity of electricity that was supplied. Okay, so without wasting much time, we'll start by saying that Q, which is the quantity of electricity supplied, Q is equal to what? Current times time. So the Q is equal to the current, which is 2.6 times the time. Remember, the time is in minutes, and we always express the time in seconds. So we say 70 minutes times 60, that will give it to us in seconds. Okay, so we have Q equals 2.6 times 4,200. So when you multiply 2.6 by 4,200, it will give you 10920 coulombs. 10920 coulombs. So this is the quantity of electricity that was supplied through the solution of the silver salt. Now, remember that the charge on the ion of an element is fundamental to the quantity of electricity that is passed into the solution of a salt. What do I mean by that? Every element has a particular charge on its ion, and that determines the number of Faradays of electricity that you need to discharge 1 mole of that particular element or ion. For example, monovalent ions like sodium ion, all those group 1 elements, silver, they require just 1 Faraday of electricity. And 1 Faraday of electricity, when you change it to coulombs, is equivalent to 96500 coulombs of electricity. So what does that imply? It means that you need 96500 coulombs of electricity to discharge 1 mole of a monovalent ion. Now for a divalent ion, you need 2 Faradays. What it means is that you need 2 times 96500 coulombs of electricity to discharge 1 mole of a divalent ion. For a trivalent ion like aluminum ion, of course, you need 3 Faradays of electricity, and so on and so forth. So in this question now, we're talking about silver ion, and silver is one of the monovalent ions, so it requires only 1 Faraday of electricity. So we'll state that in our, write it down here, that 108 grams of silver, which is the mass of 1 mole of silver, 108 grams of silver of Ag requires, fundamentally, it requires 96500 coulombs of electricity. Therefore, X grams, that is the quantity that will be discharged by this, the amount in grams that will be discharged by this quantity of electricity, that is what we call X, and that's what we're going to look for. So X grams of silver requires 10920 coulombs of electricity. So by the time I cross multiply, I will have 108 times 10920 coulombs of electricity. Okay, so divided by 96500. Okay, when you multiply this and divide by this, it will give you 12.2 grams. So what does that mean? That 12.2 grams will be discharged at the cathode if 10920 coulombs of electricity is supplied through the solution of silver salt for 70 minutes. Alright, now let us see example 2. So this example 2 is another type of question you can see under first law. So this one says, how long, example 2 says, how long will 3.5 grams of copper be discharged at the cathode, when a current of 1.8 amperes is passed through a solution of copper salt. So we have copper, the molar mass of copper being 63.5, and we have 1 Faraday of electricity being equal to 96500 coulombs of electricity. So you can see that there's a twist in this question. This time around, the quantity of electricity supplied cannot be calculated directly by using current times time. We cannot calculate it using current times what? Time. But we'll look for another way of getting it. So it's like we are going to come from the back side. Remember that 1 mole of copper weighs 63.5 grams and it requires 2 Faradays of electricity. So 63.5 grams of copper requires 2 times 96500 coulombs. Now this statement is fundamental because it's even here in this bracket in the question. 63.5 grams is the mass of 1 mole of copper and 1 Faraday is for 1 charge. So since copper is divalent, it will require 2 times this quantity. Okay, that's what we say. 63.5 grams of copper requires 2 times 965 coulombs of what? Electricity. Therefore, this mass in the question will give us the quantity of electricity that discharged it. So 3.5 grams of copper requires X coulombs of electricity. X coulombs of what? Electricity. So we simply cross multiply. Cross multiply. So when we cross multiply, 63.5 times X will give us 63.5X. And that is equal to, when I cross multiply from this side, I have 3.5 times 2 times 96500 coulombs. So X will be equal to 3.5 times 2 times 96500 divided by 63.5. So now I need to use my calculator. Use my calculator. So I have 3.5 times 2 times 96500 equals divided by 63.5. So that will give me 10637.8 approximately. I have an approximate value of 10637.8 coulombs of electricity. So this is the quantity of electricity that discharged 3.5 grams of copper. So from here, I can now find how long. How long simply means the time taken. And don't forget that Q is equal to current times time. So from here, I would simply make the subject of the formula. So T will be equal to Q over what? I. That is the quantity of electricity supplied divided by the time taken. I hope you can see what I'm doing from there. So we have 10637.8 divided by the current supplied, and that current is 1.8 amperes. So I will engage my calculator again. So we have 10637.8 coulombs divided by 1.8. Divided by 1. So that will give us 5909.9 seconds. So that is the time, how long it will take for this quantity of electricity to be discharged. That is how long it will take for this quantity of electricity to be discharged. Okay. All right, welcome back. Next on our list is Faraday's second law of electrolysis. Faraday's second law of electrolysis states that when the same quantity of electricity is passed through different electrolytes, the relative number of moles of elements discharged is inversely proportional to the charges on the ions of the element. What does that mean? If I have two solutions, copper sulfate and silver nitrate, and I pass the same quantity of electricity into these electrolytes, the number of moles of copper that will be discharged in the first cell and the number of moles of silver that will be discharged in the second cell is inversely proportional to that quantity of electricity that I supplied. Now, without wasting much time, I will go to solve one calculation involving Faraday's second law. Now, I'd like to state here that whenever you are solving calculation on Faraday's laws and you see two or more solutions in the question, that means you are directly solving calculations under Faraday's second law. That means that question is from Faraday's second law. Now, let's look at this question. Two solutions in series are electrolyzed. Two solutions in series are electrolyzed. Electrolyzed, I hope you can see from there. Electrolyzed using the same quantity of electricity, using the same quantity of electricity. The first one is an aqueous solution of silver nitrate. The first one is an aqueous solution of silver nitrate. And the second one is an aqueous solution of a salt. Is an aqueous solution of a salt whose formula is N2SO4. The relative atomic mass of M, is 48. I said if 0.16 grams of M deposited if 0.16 grams of M deposited from the second solution, if 0.16 grams of M deposited from the second solution, if 0.16 grams of M is deposited from the second solution, what is the mass of silver deposited? What is the mass of silver deposited? All right. Now, when such a question is given to you, the first thing that you need to do is to first of all find out the quantity of electricity that was supplied. Because this same quantity of electricity that was supplied to the first cell is the one that was also supplied to the second cell. So it is fundamental. Now, for us to find the quantity of electricity that was supplied, we need to start with the one that particular solution that discharged certain mass of the element. So here, the solution that discharged 0.16 grams of M is the second solution. So we start from there. Now don't forget that the relative atomic mass of M is 48. So that will be our starting point for solving this question. So we say that 48 grams of M, and from this formula, without doubt, we know that M is a trivalent what? Ion. From this chemical formula of the salt, we can see that the element, the metal M, has the valency of 3. So that 3 we are seeing there will determine the number of Faradays of electricity that will be required to discharge 48 grams of the metal. Alright, so 48 grams of M requires 3 Faradays of electricity, which is 3 times 96500 coulombs. So now therefore 0.16 grams of M will require S coulombs of electricity. It will require S coulombs of what? Electricity. So when I cross multiply, I'll have 48x being equal to 0.16 times 3 times 96500 coulombs. So x will now be equal to 0.16 times 3 times 96500, then divided by 48. So at this point, I would like to engage my calculator. All right, so we are looking for the final answer, and here we have 0.16 times 3 times 96500 divided by 48. That will give me 965 coulombs of electricity. So that will give me 965 coulombs of electricity. So now this 965 coulombs of electricity is the same quantity of electricity that was supplied in the first cell. So I will now use it to answer the question that says that we should find the mass of silver deposited in the first cell. Now don't forget that 108 grams of silver will require 1 Faraday of electricity. 108 grams of silver will require 1 Faraday, requires 96500 coulombs of electricity. Therefore, X grams of silver, which is the one we're looking for, will require this quantity of electricity that was supplied, which is 965 coulombs of electricity. So by the time I cross multiply, when I cross multiply, I'll get the value of X. When I cross multiply, I'll get the value of X. So we have 96500x is equal to 108 times 965. So x will be equal to 108 times 965 divided by 96500. So obviously what you have here is almost simple as saying 108 divided by 100. So 108 divided by 100 will give us 1.08 grams of silver. 1.08 grams of silver. So we are going to solve another calculation, and that is very, very unique. This calculation I want to solve now is very, very unique, so you need to pay attention.